Well, Peter, I just want to say thank you and the Sol Foundation for giving this opportunity, not just for me to come up here in front of these folks, but for everything over the last 2 days. It's been really great. I think one of the things that I find so interesting about these engagements, and hopefully those in the audience feel the same way, is it's really important for us to listen to and embrace diverse perspectives, such as those held by the last speaker, so we can continue to flex all the muscles that we need to really understand this phenomena, and from both an advocate and a non-advocate position. So I think that's great too. And plus, you always get surprised by things in this environment. And like the discussion yesterday about Bootsy Collins and George Clinton and the whole experiencer side of Parliament Funkadelic. I never in my wildest dreams thought that I was going to get any of that here. And so that was really refreshing, and I just think that was great too. So yeah. And one other thing, I mean, for all of us that are here, and now we're into our second day of this, I think it's important for us to avoid what I call astonishment fatigue, which is kind of let's say you're out in the driveway talking to your next door neighbors, and one runs a restaurant, the other one is a physician, and then the person across the street might have a tire and brake shop, and you're talking about your day after work, and they say, oh, I saw this patient, and I had 400 people in the restaurant today, and maybe the person other said, well, I sold a lot of tires or whatever, and you say, what did you do? And they say, well, I fed Bigfoot. And they look at you like, you did what? And I'm like, yeah, I mean, it's just a job. I get the bowl, and there's some corn and chop, and maybe on Sundays there's some ice cream in there. But, and they're like, no, you feed Bigfoot. You really don't know. It's just, it's just a job. So anyway, I think it's really important for us that we continue to really recognize that our understanding of this phenomenon and the way that we feel about it and the things that we have to try to advance it is not something that just everybody gets a chance to do. So thank you for this chance and opportunity to do this.
Wow, great.
Thanks.
Well, thank you for that, Eric. And you did so well with jumping in that I'm not sure, you even need a partner on stage. So,
you're my partner.
So I think, to get started, just tell us a bit about who you are. I know you want to avoid astonishment fatigue, but I think you've done some very interesting work in your career. You had very interesting career so far, and I think people would like to just get a sense of who you are because you're not known in this space.
Yeah. Okay, so ever since I was a kid growing up in the middle of nowhere in western Pennsylvania, I've always wanted to design airplanes. And the reason why is that I think out of all of the things that we as human beings create on this planet, and there's a lot of wonderful things that we've done, aircraft are the most direct and intentional, and from a form follows function part of design. And because of that, that's a really rich experience, right? Lift and drag and thrust and weight, they all have to balance. So airplanes look very purposeful. They do the things they need to do. And that really appealed to me. And so I was able to, find a career doing that for an outstanding company, for one that made all of my favorite airplanes as a kid growing up. I don't know about you, but things like the U-2, the F-104, and the SR-71, I mean, just outstanding examples of flying machines. And I was able to do that for a while, and then do the development of technologies to go into those flying machines to try to make them better. And I've been really fortunate to do that. And since then, I've been on the board of advisors for Quantum Frontier, which is looking to do some interesting things in the advanced technology space and find applications and transition of those to practical problems. And given my previous job, that was a good fit. So
if I found you, you were involved in the development of aerospace technology.
Yeah, right. Mm-hmm. But my experience, let me say that the reason why I'm here, is not really a result of my engineering career. It's just from a long-term interest in this particular phenomena. Because if, going back to my initial assertion that aviation machines, flying machines, are the most intentional things that we can design, if there is something that can do what UAP evidence that we have collected shows that can be done, wow, that's even cooler, right? Wouldn't we want to understand what that is and how to do that. And so that's just been a long-running interest of mine, totally separate from my career. And it's nice that we can get together and discuss that.
Well, so give me in the audience a sense of how you developed advanced and cutting edge or just novel aerospace technology while you were working in that sector.
Okay.
If I understand, you were often leading development efforts.
Yeah, well, leading teams that do the development efforts and so on. When you have a certain technology, and this is, I'll talk about different groups of technologies, whether those are airplane technologies, things like propulsion, aerodynamics, controls, right? Or mission systems technologies, because even though I am an airplane designer at heart and I love the way they look, the fact is they don't get off the ground or really do anything unless the mission systems are there in terms of the radios and systems and weapons and sensors and software and computers and all that stuff you need to do to actually have them do their job. So there's a wide range of technologies across all of those things. And because aviation is not like automobiles. If we have a problem, we just can't pull off the side of the road, turn the signal on, get out, jack it up, and see what's going on, big safety of flight concerns. There's a lot of regulation. There's a lot of, when there's regulation, there's going to be bureaucracy, all in the name of safety and performance. And what we tried to do in developing these enhancements for the technologies that I mentioned is making sure that, one, they are valued throughout the whole ecosystem. And from that, I want to come back to the topic of innovation, which is going to be real important, because this ultimately is a business discussion, right? Innovation defined, a lot of people think, it's just coming up with good ideas. I innovated this, I innovated that. But really, if you look at a good, strong definition from a business perspective, it's the creation of a product or service that adds value in a competitive marketplace, right? So in developing these technologies to make something better, airplane, right? You need to make sure that there's value in that. One, value for the ultimate end user, which in the case of a lot of those things are military values. So we need things that do their jobs better from a military perspective, whether it's more reliable, more lethal, can just get its job done, right? And then also more value from the organization that's sponsoring it so that it has a revenue stream associated with it, because we have to make sure that you can make money off of things like that. And the important thing to understand there is that technology for technology's sake is not always an innovation. Isn't that interesting? Because we think, I came up with a new idea, it's a great technology, but really, if you take that definition of innovation, it is, hey, can I capitalize on this? Can I add value to something for it? And that's the challenge. And so in order to do that, to make a technology that's viable in the airplane business, you need to make sure that you can get funding to do that, and then you have to be able to get buy-off through all the different levels that it takes to actually get it from somebody's idea to the ramp and on a jet where it can be used to hopefully, in this case, defend our nation better or move goods or services faster if it were a commercial innovation.
It's mind-blowing to me, not having dealt with organizations at that scale, that anything works right, that anything comes off. And when you're dealing with the sorts of aerospace technologies that I think you're working on, it's even more remarkable because they can't fail.
Right. Yeah, the standard for success is pretty high because we as a nation depend on those things working whenever those folks that are called upon to defend us need them to work.
Okay, so with a background like that, it's interesting that you are interested in UAP. So how did you get into UAP?
Well, just from an understanding and looking at these technologies, if this can do what it purports to do, then one, from a competitiveness perspective, and let's look at competitiveness on two levels. One is just from a national security perspective, which we've talked a lot about here today and yesterday. That's kind of self-evident, but also from an economic competitiveness perspective. If you look at so much of our export of this nation, one of the things that we provide is aircraft, and if we can gain competitiveness there through new technology, then that's incumbent upon us to be ahead in that area too. So those are two reasons that I see. And also I think just it's important for us to further our understanding of ourselves and our relationships to everything else here on this pale blue dot, I guess, as Carl Sagan would say.
Okay. Well, it seems like you've been into the topic for a long time. It wasn't just something you got into a few years ago, but here you are coming out of a long and very successful career in aerospace. What makes you think now is the time that we could actually start talking about, thinking about a plan for developing technology like this, or even trying to do it?
It's not just me, right? I think there's a lot. The stigma is slowly being lifted on this topic, right? We see a lot of people talking about it in open spaces without like the slings and arrows of being called a tinfoil hat or a flying saucer crackpot. You see the testimony that was given before Congress, and the thing that I find truly amazing there is that that's a bipartisan thing. In this day and age, what could be bipartisan? Man, if it takes space aliens to do it, okay, I'll take it. But the fact that we're getting out there and doing that, I think it's a good time. And because of that, there's going to be more of the things that you need in order to make this successful. Whether, again, coming back to this being a business discussion, people might be more inclined to think that it can be done. People might be more inclined to invest in it, and people might be more inclined to try to shape a career in this particular field.
Okay, interesting. So, what are your thoughts about how we might conceive of UAP technology and UAP themselves that would allow one to actually make some progress in thinking about how they work and then trying to emulate or develop the technology?
Okay. Let me go and talk a little bit about aircraft technologies in general and look at that from a historical perspective, and then we'll see how UAP might fit into that. So bear with me a second as I think about this. I think technology in general, the kinds of technologies that we see in the airplane business, they exist on a kind of a continuum. And that continuum is from like energy technologies right here to information technologies over here. And it's not just technology. Think about energy and information could be things people even fight wars over it, right? There might be energy in the term of like natural resources. I might want to go and make me want to invade your country to get that. Or it might be water, it might be food, it would be something like that that leads me to energy, right? Likewise, we could have mighty struggles over information too from an ideological perspective or a religious perspective, something on that continuum. So energy and information, a lot of things line up with that. But if I think about the stuff it takes to make airplane successful, you can think about technology on the same spectrum. So on this energy side, I've got propulsion technologies, obviously, right? We have things like the motors themselves, whether those are jet turbine engines or propellers or rotors on a helicopter, and it's also the technology it takes to integrate them into an airplane. It's a living, breathing system. So if you take an analogy to a race car, it's not just the crate motor that you care about, but how well you get the horsepower to the wheels. So it's all the inlets and nozzles and offtakes and all that stuff, right? So energy, propulsion technologies. Then we come back a little bit more towards the information side, and the first thing we see there is like aerodynamics, how the vehicle is shaped. And then we start looking into structures technologies because the structural technologies, the materials you make it out of, the way you build it, how you actually manufacture it, those things determine how much it weighs. And if I know how much drag it is and how much it weighs, that influences one key bit of information, and that's where you put the throttle on the thing to make it fly right on the motor. And then as we come up a little bit higher into that technology spectrum, I get flight controls technologies, because with the manipulation of flight controls, I give the information from a pilot or a computer that wants to put the airplane in a different energy state. Okay? So working up through energy technologies, propulsion controls, and on up to that. In the middle of this spectrum is kind of the stealthy technologies, right? Because in there, you've got radar that might be illuminating an airplane, which is energy, but due to those technologies, I corrupt the information that the receiver gets back, and it either doesn't see me or thinks I'm somewhere else. And then as we move up the information track a little further, I've got sensors that take some energy, but they give back an information picture of what's going on. It could be radar, it could be infrared, it could be laser, something like that. And then I have electronic warfare too, where I just generate a lot of energy and throw that out there to try to jam somebody's radar or sensors. Going up a little bit further, I start to have information technologies that have a little bit of energy consumption in terms of a radio that allow us to communicate. or a mission computer that takes energy but then processes information on board that aircraft to help it fly, or to take in a whole bunch of data from sensors and present a common picture. And then there's the software, the pure information stuff that lives over here that are all the applications that you need to run that system, right? It could be targeting, it could be battle management, it could be sensor fusion, all of those things on that side. So, and then you can see how this spectrum then is stuff an airplane needs, from the energy side all the way through to the information side. Now, if we look at this historically, and we go back to like before the Wright brothers, you had the glider boys like Chanute and Montgomery. They only had this one part of it. They understood lift and drag, that was about it. It took the Wright brothers to really get two big innovations that they needed in order to get something to fly. First thing is they had to have a lightweight propulsion system. And being a bunch of bicycle guys, they kind of figured that out, right? And then they had to have a viable flight control arrangement too, because think of like all the magnificent men in their flying machines that would just, you know, crash and wreck spectacularly, right? So the Wright brothers kind of had to have those two things figured out. And in doing so, now they established that part of the spectrum. They had propulsion, they had aerodynamics, they had flight controls, and they had structures. And that really kept us going for a while, right? Not until you got to like World War II, you started implementing weapons and some crude sensors, and we're looking around with binoculars, or World War I with that. And then World War II got a little bit more established. You had more reliable communications and radios. At the time of the Wright brothers, really the only radio thing you had was like Morse code. So think about how far that had to come. And those are pretty big innovations to get those in a way that they could be reliable and be put on an aircraft. Then you also had radar. The Germans and Brits were back and forth with radars flying and during the Second World War. And then the German invention of the jet engine, and the British too, really pushed that end of the spectrum a little bit in World War II. And then go a little further down, Korea, Vietnam, we established more reliable sensors, guided weapons, air-to-air missiles, things like that, pushing it more this way, more powerful engines this way. And then even up to the F-117 and the Gulf War totally revolutionized air warfare with the application of real stealth in combat. And then you come out to where we are today with things like the F-35 with incredible software and sensor suites that present a common view to the pilot to really like dominate what they need to do. So that spectrum, you can see how over time, Wright brothers, World War I, World War II, Vietnam, Korea, and all the way out to the F-35, you've got this spectrum, and it's kind of grown that way in time. Now you add UAP into the mix.
Okay, so just for the sake of the audience, if you could sum up what the energy information spectrum is, like, concisely, what is it?
I think it's a great approach. Maybe not great, depends what you think. I think it's one way to look at the history of aerospace technology and kind of quantify the things that we need to do on a continuum that is readily explainable, and it maps into a bunch of different things. History is one of them. Also, the time it takes to develop these technologies. Things on the energy side of the spectrum take a lot more time. Things on the information side of the spectrum can be turned a lot more quickly. In the case of electronic warfare, if you notice an adversary doing something different to you, you monitor that, you change it, and then you update your techniques. That can be iterated really fast. If you need to build a new motor, well, that could take some time, especially if it needed to have better and different performance. I mean, if you really want to look at rapid innovation cycles in aviation right now, take a look at what's going on with drone warfare in Ukraine. They're turning things over really fast as they have a counter to what the Russians do, and back and forth and back and forth and back and forth.
So given the way you're conceiving that spectrum, how would you kind of slot UAP into this to make sense of the performance characteristics and morphology and so on?
So just like all of those innovations kind of added and widened our spectrum as we got further along in history, UAP do that, and I think they blow it wide open. Let's take the Tic Tac incident, for example. We're dealing with something on the energy side that had radically different propulsion systems and radically different control. If you have that much power, you really have to be able to manage it intelligently and be able to work through the control side of that as well. So that's truly admirable, and don't know how it works, but boy, we should figure that out. Just remember, take a note on that when you figure it out. On the information side also, there's a lot of advantage that is displayed there that we don't know how to do yet. For instance, how it went to the pilot's cap point and they had no idea that it was going to be there. How did it know that? What kind of sensor is that? What is it plugging into? And if you look at that energy and information, I've kind of just described it as a continuum by gesture in here. I asked Peter, I said, hey, can I get up and move around the stage and doing this? And he was like, maybe you shouldn't because it might make this guy's life really hard. So I didn't do that or else I'd be running around. But if you look at that energy and information side, maybe with UAP, maybe the two turn around and connect and back. So the phenomena that you're seeing is either energy infused with information or information infused with energy, kind of like the old Reese's peanut butter cups. You got chocolate, my peanut butter, but and maybe that's how that connects. And if we think about it that way, that might provide us some insight. Or you could look at it all along that continuum, and maybe there's a third dimension to it as we infuse these different fields and ideas. If you look at, his name is Laszlo. Laszlo, and he believes in an information field that contains that, and maybe that is a way that this does as well. So there's, you can have propulsion infused with information and all the way up and down that spectrum. Somehow or another, there's a missing piece there somehow that either makes this connect or diverges it across into a third dimension. Those are just notional thoughts. I think if we'll go back to the Wright brothers, and let's say that they had the opportunity to see what an F-35 would do and understand that. I don't know how they would approach that question, but I think we're looking at it kind of similarly, like what those next steps might be.
So if you had to unpack the different components of what is probably making a UAP vehicle work, if they are what we think they are, what are the different components, the different systems, the different areas of knowledge you'd have to have?
Just march down the line. There's a propulsion and control aspect that is remarkable. And I think that you would want to understand what could be construed as aerodynamics in terms of its movement through a medium, whether that's space, air, or water, however, or if there's a way that it actually gets it out of the way so it doesn't have to worry about it. There's also, certain accounts say that these things have or have not shown up on radars and with different sensors. So there's a observable technology piece of that as well. Maybe with some of the things that are happening, you might get that for free if you really are indeed getting things out of the way and traveling in a bubble or something like that, right? And then on the information side, I think there's a lot of things to be explored there too, either from a sensor perspective that helps it steer and affect its own control, all the way up to how it interacts with its own occupants, right? Because if you think about some of the technologies that we can see on the information spectrum, just based on what we have, one of the next ones that might come on that might be like a neural interface, So what if there's something equivalent to that, but without having to wear an EEG hat or something that can be done there as well? So I think all of those different technologies are places to look. But, just like the Wright brothers, if you showed them an F-35, they probably wouldn't go try to do that right away. I think you have to wait and be patient for that spectrum to build itself out. But if you know the direction you want to go, that's a great first step. So you can start to work things in those different areas to start to push that envelope.
And so, if you had to do it, if you had the budget if you had $1 billion today to do this, and you wanted to, and you could do anything you wanted to just try to start to move things. Yeah. Where do you start?
I think so that's a great question, but it's a little bit unrealistic. But a lot of the things we do here is unrealistic, so I'll take it. I think you would start with some basic science in some key areas to try to find out what the physics are to build a model so that then you could exploit those technologies and see how real they are. And I think from a business and an investment perspective, that would be the first place to go, because you would want to try to demonstrate smaller innovations so you could find and sustain those businesses, because I think those things are going to happen before we go and start like a UFO production line somewhere in Kansas or something like that. We're going to want to figure out these different pieces. And in doing so, what's going to happen? We're going to find a bunch of milder but smaller and still very impactful innovations that will be able to be capitalized upon and start new businesses. And chances are, those, if you think about it from a business perspective, it's probably not going to be your large established communications, hardware, aerospace firms that are going to be the ones to do that. For instance, like, GM had a great electric car in the 90s. Kodak made a wonderful digital camera, but they weren't the ones eventually to take that on. It becomes the people that don't have to disrupt themselves first to do that. They would just own the disruption and make it different all on their own. So that's a room for a lot of new businesses, new thoughts, and entrepreneurship, which is exciting.
So given where we are today, where we're really looking at we're looking at birds flying and wishing we knew how to fly. I have the sense that that's about where we are based on what you've said. What is the role of academia in this, in entrepreneurship in this, and in industry, if we want to make some kind of start and eventually have some progress?
Yeah, excuse me. I think academia, forward-thinking academics that are also very humble, because I think you have to approach this topic with a ton of humility. If you go in thinking that you know all the answers, or if somebody approaches you that thinks they know all the answers, just turn around and run the other way. I mean, that's pretty scary. Thank you. I don't know if I would probably run faster away from that individual than I would if it was an alien, only because, I'd have more questions for the alien. I would just want to get out of the other person's way. So, you would want to make sure that people are addressing this in the right way from an academic perspective. And then from there, they could help fuel that incremental research to, find new innovations. And in some ways, that might look like a battery that never wears out. In some ways, that might look like a control system that moves super fast. Some ways, it might look like, a different set of materials that would be super lightweight and yet could conduct electricity or something. Who knows? So, those sorts of things from an academic standpoint. From a business perspective, I think having the right environment there is really important too. People that take those small innovations and generate revenue from them that are established by the academics is one step, but the other part is the funding community too. And if I can go back to that energy and information spectrum for a minute, on the energy side of that spectrum and on the information side of that spectrum probably looks a lot like, from a business orientation and a funding perspective, it probably looks a lot like today's venture capital, software, and computing hardware kind of environment, because the innovation cycles are short. The payoffs can happen over the time scales that we're used to. Now start moving this way into the information side, and all of a sudden, things start to get a little bit more expensive, a little more capital intensive, and they could take projects that could take a long time to create. For instance, if we wanted to make a collider on the moon or something like that, find an investor for that. That's going to be a tough one, because you're going to need a lot more patient capital, and sometimes even somebody that would be an emotional buyer that would be willing to invest just based on the promise of the technology and not really looking at a payoff in terms of a horizon that's close. So I think that's something else that spectrum can help advise. The last thing you talked about was industry. I think that industry should probably look at this in a different light, and from a disruption perspective, and really say, hey, there's these things out there that what are the threats to my existing place in the market, and are these something that I should be preparing for? And then watching what happens to the entrepreneurs as they start to get some traction.
Okay, so with coming to a close. People interested in science, technology, engineering in the area of UAP have a lot of hope. They're dreaming a lot. You're giving us some realism about this, but you're also giving us a sense of possibilities. What's a word of encouragement you would have for a young scientist, a young entrepreneur, a young technologist who wants to get involved in doing something like this, say in the next decade, if it's possible?
Yeah, I would say always be open to possibility. Establish yourself firmly in the existing science. in the existing technology so you understand its application, where it's coming from, and so that you have credibility in the light of everything else that's happening around you. And then never take your eyes off of what can be, because those are things where you're going to find the real payoffs and get us out of the environment we're in right now. So I guess somebody has said once that, only a group of small people that are very committed to advanced technology can change the world because it's the only thing that ever has, or something like that. I think I botched it, but you know what I mean. I would encourage them to be those people and go forth and try to make a difference in that.
Wow. Thank you, Eric.
Thank
This is
you.
great.
Yeah.